So what I've got here on the bench then is a Netgear Wi-Fi range extender. It's a pretty common Wi-Fi range extender. It's not that much to buy. I think I paid about £22 for this. It is new. I didn't buy it second hand. I've had it in the lab now for quite some time, and I have a friend that's just moved house and he's having particular problems with the Wi-Fi in his house. So he asked me what he could do to improve that, and I remembered I had one of these. So what I'm going to do is try and modify this to make it even better. They're not bad, these, apparently, as they are, but they do tend to drop out every now and again. When it's been on for a few hours, it'll all of a sudden just lose signal, and then a couple of minutes later the signal comes back, which is one of the reasons I would have liked to have put something like DDWRT onto this, or something similar. But unfortunately you can't do it with this one, or should I say that Netgear have made it extremely difficult to do it with their new products now. They're really clamping down on people putting different software to the manufacturer's software on these, making it more difficult. So I'm not going to go down that route. But I thought, if we can modify this, make the antennas a little bit better, get some more range out of this, then it should suit his purpose. This is the WN2000RPT, and this is the version 3 of this particular model. I think the earlier versions were a little bit more easy to put some, like software on, like DDWRT, but this one is extremely difficult. You need to do some hacking on the inside as well, and communicate with this in a different way than you normally would. It's not as simple as whacking the software on and rebooting it and you're good to go. They are trying to make it a little bit difficult for you now, and the only thing I can think of to make manufacturers start to do that is to stop you from putting the software on, because the software allows you to extend the life of a product like this, and it tends to work a lot better than the manufacturer's software, so you're less likely to go and upgrade. So the only thing I can think of is the fact of money, and people aren't upgrading to the newer products as the manufacturers release them. I don't know, haven't been part of that scene for many years. So I've never opened one of these up before. I've had a look at a few photographs online last night, and the different versions tend to be a little bit different. Some of them have got 2 antennas in here, some of them have got 4, but it looks like it's just a simple torque screw off here and then prise the lid off. So let me do that, and we'll get to see what's inside, and then we can make a decision on how we're going to modify this and what we're going to do to modify it, depending on what we've got to work with in here. So this is definitely the only screw to remove, and the main motherboard, you can see here it's upside down, is just held in by plastic clips. So there's only that one screw holding everything together. So I'll just get my spudger and gently pry out this motherboard. So this board then is going to be extremely easy for us to modify, because they've got the 2 antennas here. There's a PCB antenna there already etched into the motherboard itself, and we've got this metal one over here, and they're connected by coax. So it's just going to be a simple modification of desoldering this coax and then soldering the coax on there to whatever antenna we want to connect to this. But it's interesting that there's a 3rd antenna here that's not used. It's etched into the motherboard itself, and I think the reason is that they're not using that is because this one is in the horizontal, depending on how you stand this up, because you can stand it up on its end, or you can lay it on its side. So if they've got an antenna in the vertical and another one in the horizontal, then they've got the bases covered for the best signal, depending on how your laptop is positioned, of course, and how they're laying this down. So that's probably why they've done that and decided not to use that antenna there. But I did think that this antenna was a 5 gigahertz Wi-Fi antenna, but it's not. It's definitely a 2.4 gigahertz antenna. I have seen this pattern before on a similar router, and I think that came from Netgear as well. Now, when I was originally thinking about modifying this before I opened it up, I was kind of thinking of we could possibly leave one of the antennas working here on the inside of this range extender here, and possibly build a cantenna and fix it to the top here, a short cantenna, which would then make it directional. You can just move that by positioning the extender itself. What I'm thinking now is to possibly have two bulkhead SMA connectors connected here at the top, so that way it makes it more versatile, because you can choose your antennas that you want to put onto this, depending, you know, when you get it in your house, and you can choose which antennas are going to work best for you in your house. So what I'm going to do is just replace these two antennas all together and solder on some SMA connectors, so we can just screw the different antennas in the top there. We can have an omnidirectional one and a directional one, for instance, and it just makes it a much more versatile unit. And I don't really understand why manufacturers aren't doing that more with their products, because I'm pretty sure, you know, if they started producing more cheap products with things like SMA connectors on, so you could swap out the antennas, I'm pretty sure they'll sell a lot more units than what they do now, unless they just want you to buy this and after 6 months, you know, realize it's a piece of crap and then go and buy the next product. I don't know whether it's a money thing, but certainly if a manufacturer came up and made you know, a value range of router, for instance, that had external SMA connectors on, I'm pretty sure it'd be a good seller, even if you couldn't put different firmware on there. I'm pretty sure, you know, it'd be a good seller for them just by having the fact of having some SMA bulkhead connectors on there. So to connect to this Netgear range extender, then I'm going to be using these bulkhead SMA connectors. Basically, I can drill a hole through the top of the casing, insert one of these, and then lock it down with the locking nut on here. Now, I was going to use a couple of these ones, and I have got some somewhere in the lab, I just can't lay my hands on them, so I've picked out one of these to use instead. So I'm going to use this one and this one. It's just got slightly thicker coax on this one, that's all, but it just makes it a little bit more difficult to solder it in place, but it's not impossible to do. It's just a little bit neater with the thinner type of coax like this one here, but you can buy them already made up. This one is one that I've made myself with some crimping tools, but you know, if you're just going to modify one thing like this, then, you know, buy them already made up like this. They're only a few pounds each off eBay, even cheaper if you can wait for them to come from China. And it's really simple. I'm just going to cut the high rose connector off the end of here, strip it back, and then solder it on in place where this coax is soldered on here onto the motherboard. So really simple modification. So before I solder the pigtails in place, I want to decide where I'm going to drill the holes so that they can come up through, and then we can connect to them. So I've just popped the motherboard back in place, and you can see there it takes up this much space right up to the edge of here, using these little dots as a guide. So I'm going to be drilling my first hole around this position here, and then I'm going to drill the second hole all the way over to this side and around that position there. I want the antennas spaced quite far apart. You know, they will work better spaced quite far apart rather than next to each other like that, especially if you want to leave an omnidirectional one here, and then you're going to connect a pigtail on this side to connect to a cantenna or something similar as a directional antenna. So as far apart as I can get them, drill a hole in these two areas here, and that will give me plenty of clearance from the motherboard itself. So a little tip to use when drilling through plastic, I always use a wood drill bit, and what I do in a situation like this where I've got holes all over the place around the hole I want to drill is use a thin piece of wire, heat it up, melt yourself a pilot hole through there, and then you can use the little guide on the wood drill bit that goes into the pilot hole there, and spin it up quite slowly, not too fast, and it will drill a nice hole through the plastic like that one without cracking it. So you can see the two SMA connectors fitted in place there. They sit nice and flush on the top. They're not too close to this edge here, so they're not you know, sitting skew with. You know, if you're doing something like this, really take the time to plan out where you're going to drill a hole, I mean, the amount of times I've done something like this, drilled a hole in the wrong place, either there's not enough room inside because it starts interfering with components on the motherboard or inside the case itself, or I've got it too close to an edge like this and it doesn't sit nice and flush. But those two look good, so let me remove these now and we'll get on to soldering these onto the motherboard. So I'm going to desolder the old coax first, which is a little bit tricky. You've got to get some heat in there. I want to desolder the ground first. There we go, and then the signal wire, like so. And the same with the second one. I'm doing this on camera as well. I don't know if you've ever tried to film soldering on the camera, but it is very, very difficult. So I've just cut the coax so I can get a little bit more leverage and try and get underneath there to get the heat in. There we go. So now that they're desoldered, I'm just going to get in there with the iron, clean it up a little bit, flow some new solder on there, ready to solder the new coax in place. So I've removed this metal antenna because we don't need it anymore. I'm just getting ready to solder the coax in place, but I just wanted to show you this. It was held in place with some double-sided tape, and the double-sided tape in the antenna sat over the top of this antenna that's already been etched into the board and they didn't use for some reason. But this wasn't actually ground into this, but that is a bit of a risk, you know, popping that on top of there like so. I mean, if this grounded out to that, then effectively this is no longer an antenna, it's just a piece of metal. It's not going to, you know, work in any way, shape or form as an antenna. But that is extremely dodgy. It's just a risk, you know, if somebody just put a little bit of force in this area here, and you know, possibly if you didn't put double-sided tape all the way down here, you're running the risk of grounding that out to that PCB antenna. So that's actually quite bad. Now I've prepared the coax, I've pre-tinned everything there. I've pulled back the outer braid all around each length of coax and soldered all the way around there. So hopefully now I can just pop that in place, put the soldering iron on top of that outer braid, and heat transfer will go all the way through the solder and solder it in place onto that solder pad there, and then just tack in the signal wire there onto that solder pad, and the same with this one as well, a little bit thicker. Now I'm using the thicker one on this solder pad because this one's just going to go straight up to the top, where this one is a little bit more flexible, so I can bend that around to connect this one to the top of the casing. So that's why I've chosen to put that one there and this one here. So I've got just a little bit of solder on the end of my iron just to transfer the heat. Just get that around there a little bit. Now hopefully I can move this into position. And solder that down into that pad. Now I just need to solder the second one in place. So I've got them both soldered in place. I went a little bit cockeyed with that one because I was doing it on camera, but it's still soldered down pretty well. But this one's a little bit tidier because I did this one off camera. So you can see I've got the outer braid soldered down onto that pad there, and then the signal wire coming down and soldered onto the signal pad. So I've got the bulkhead SMA connectors bolted down onto the case, and you can see I've got this length here that I can play around with. If it never needs to take the motherboard out, you're not going to rip them off those solder pads by doing that. So there's plenty of space to get in there and remove the motherboard and do maintenance on these. It is all finished then. I've got a dipole antenna on there, and I've got a directional small patch antenna on there, so we can turn the patch antenna into the direction that we want the extra signal to go in if we want to, and the omnidirectional dipole is taking the signal from the original router that you want to extend and then kicking it out using this panel antenna. Although both do, it picks up and transmits with the omnidirectional, so you're still getting the omnidirectional extension of that signal there, but you can use a patch antenna or another directional antenna to get some extra signal boost into an area of your house that you actually want it to go into. And a lot of people use these if they want to go and browse on the internet in their garden, you know, especially in the summer. You want a strong internet connection into your garden. More and more people are wanting that kind of thing now. But with this particular Netgear range extender, just by putting those two bulkhead SMA connectors on there, it really does make it a much more versatile little unit. And as I said in the video, I'm not sure why other manufacturers, and Netgear in particular, Belkin's another one, why they don't particularly make a router with you know, external connections like this, or a range extender like this one with external connections, because you can buy the antennas pretty cheap off eBay and you can play around so you get a signal you know, where you actually want it in your house. And you know, I'm pretty sure that even when they lock their merchandise like this down so you can't put different firmware on it, even if it had external connections there, external SMA bulkhead connectors on there, I'm pretty sure it'd sell a lot better than you know, how it would normally, and it wouldn't cost that much either, to be quite honest with you. I mean, the parts, the bulkhead connectors, are just pennies really. A little bit probably of extra you know, manufacturing time to put those into place, but there's still a lot of components inside one of these that's hand soldered anyway. The coax that were removed from this on the inside, that's hand soldered, it's not done by machine, so it wouldn't be too much of you know, an expense labor wise to do this kind of thing. So I hope you found this video useful and it's inspired you to go ahead and you know, modify your Netgear range extender or something similar, because they're all very similar on the inside, and you can do a search if before you buy one, and try and get some external photos just so you can weigh up whether it's going to be a hard job or an easy job to modify something like this. But if you did enjoy the video, then please give it a thumbs up. Any comments or questions, drop them below and I'll do my best to answer them, and hopefully you'll join me on the next one.